Today we are talking about dilations, and a dilation is when you make something bigger or smaller. Now, when we make something bigger or smaller, we do it by a scale factor, and the scale factor tells us how much bigger or smaller it's going to be. To find scale factor, we do the image over the pre-image, and pre means starting or the first image. So if you look at some of these examples here, if we have a scale factor of 2, the pre-image is going to be smaller, and then it's going to end up getting 2 times bigger for the image. So a scale factor of 2 makes it 2 times bigger. If you look over here, if we have a scale factor of 1/2, we are getting smaller. So we are making it half of its original size. So here's just some other helpful hints. If a scale factor is greater than 1, it's getting bigger. Like if it's 2, you're getting 2 times bigger. If it's 3, you're getting 3 times bigger. If it's 4.5, you're getting 4.5 times bigger. If a scale factor is between 0 and 1, it's getting smaller. So if it's 1/2 or 3/4 or 0.55 or 0.01, anything between 0 and 1 is going to make it smaller. A negative scale factor does not make it smaller. A negative scale factor actually flips it, but we're not going to see negative scale factors right now. I just wanted to point it out that for it to be getting smaller, it's usually a fraction or decimal between 0 and 1. A negative is not what makes it get smaller. All right, so given a scale factor of 3, now that means we're getting 3 times bigger. Given a scale factor of 3, find the coordinates for the dilation of the line segment with endpoints at -1, 2 and -3, 3. So I'm going to show you how to look at it graphically, and I'm also going to show you how to just do it with numbers. I kind of like doing it with numbers, so the way I would do it, since I know that I'm getting 3 times bigger, is I would just multiply all of these numbers by 3. So I'm going to multiply the -1 by 3 and get -3. I'm going to multiply the 2 by 3 and get 6. Then I'm going to multiply the 3 by 3 and get 9. And then I'm going to multiply the -3 times 3 and get -9. These would be my new endpoints. Because it's getting 3 times bigger, I just multiply everything times 3 to get my new endpoints. I'm actually not going to show you graphically because I think this is the easiest way to do it. All right, given a scale factor of 1/2. Now remember, 1/2 means that it's going to be half of its size. So it's going to be getting smaller. It's going to become half the size. Find the coordinates of the dilation of a triangle with vertices here. All right, so we get to do the same thing. When we had a scale factor of 3, we just multiplied everything by 3. When we have a scale factor of 1/2, we're just going to multiply everything by 1/2. And I want to just make a little note here that multiplying by 1/2 is the same as dividing by 2. Because if you look at 1/2, remember the fraction bar means divide. So we're doing a number divided by 2, or 1 divided by 2. So it's up to you what you think is easiest. If you think multiplying by 1/2 is easier, do it. If you think dividing by 2 is easier, do it. It means the same thing. Either way, we're going to make it half of its size. I actually like dividing by 2 better. So I'm going to go through here and I'm going to divide each of these numbers by 2, which is the exact same thing as multiplying by 1/2. 0 divided by 2 is still 0. 0 divided by 2 is still 0. 4 divided by 2 is 2. 8 divided by 2 is 4, and 0 divided by 2 is still 0. These would be my new vertices, and it would be half the size of the original. Now, if you did take the time to graph it and look at the graph, you would see that it shrunk and it became half of the size. Because instead of going all the way up to 8, we only went up to 4. And instead of going over to 4, we only went to 2. So it does make it half that size. All right, Gina uses a magnifying glass to look at a bug. A caterpillar that is 2 inches long appears to be 5 inches long through the glass. What is the scale factor? Okay, so for scale factor, I had this on the very first page, but we can go back and look at it. It is going to be the image divided by the pre-image. Whoops. So image, which means the final thing, divided by the pre-image, which was what you started with. Oops, there's supposed to be a dash right there. Okay, so if we want to find this scale factor, the pre-image, or what we started with, was 2, and what it appears to be, or the final image, is 5. So we would do 5 divided by 2, and it tells us that our scale factor is 2.5. In other words, the magnifying glass is making it 2.5 times bigger than it really is, right? Because we have a 2-inch caterpillar, when we look at the magnifying glass, it's 2.5 times bigger. So to do scale factor, you do image divided by pre-image. And this was your answer. What is the scale factor of the following dilation? So again, we're dealing with scale factor. So let's write down our formula again. It's image over pre-image. And then it tells us the smaller triangle is the pre-image. That's important. We have to know which one's which. So since the smaller triangle is the pre-image, the red one, I know that that's going to go on the bottom of my fraction. And then the blue one's going to go on the top. So if I want to find the scale factor, I really just have to look at one set of corresponding sides. I can't look at this diagonal side and really count how many spaces it is, but I can look at this horizontal side and I can say, okay, this is 1, 2, 3 units long. And then I can look at the blue one on that same horizontal side. We want to get corresponding sides. And I can say it's 1, 2, 3, 4, 5, 6 units long. So if I want to find the scale factor, I started with 3 units long and I ended up with 6 units long. And 6 divided by 3 is 2. In other words, this is getting 2 times bigger, right? If the scale factor is 2, that means it's getting 2 times bigger. And that makes sense, because if you did 3 times 2, it would equal 6. So our scale factor here is 2. All right, y'all, I hope this helps.